time travel is possible, and I'm going to use physics to prove it.
You might have heard of Einstein's law of time dilation. It states that time dilation is equivalent to the stationary time multiplied by the square root of 1 minus the observed velocity squared divided by the speed of light squared. Obviously c is equivalent to the speed of light, but v is equivalent to the observed velocity. This stated the faster and faster you go towards the speed of light, or even greater than the speed of light, almost, time starts to slow down. This effect is known as time dilation, which I've expressed as t with a little bit of a dash on top, which honestly looks like t prime, but it's actually meaning time dilation. So here you have one end of a wormhole. Imagine that's the end of the wormhole. A spaceship goes in. However, the wormhole has been stretched at high speeds through time and space, which means this time, the time here, stays normal. In other words, stationary, like 1, 2, 3, 4, and seconds, and minutes, and hours. But here, since it's going nearly at the speed of light, it's going really fast. Okay? So which means time is going to start slowing down. Okay? Now, the thing is, even if you did have a really fast spaceship, and you could even find a wormhole, your spaceship needed, or spacecraft, needed to have anti-gravity. The reason is, in that anti-gravity, you cannot feel that, you cannot go through, since the pressure of a wormhole is so really, really condensed, and you need to go inside the wormhole, and that anti-gravity will allow all the edges to, you get to levitate all the edges, and then go through the wormhole. Now you might think, okay, I see a wormhole here, this, thousands of light years away, but hey, I don't need to go through the tunnel. Going through the tunnel, and if you calculate it, you'll find that, well, it's just going to make things harder for me. But the thing is, if you went this way, it's the same linear distance. But it's not linear. The reason is space and time is curved. This is how you would conceive it. But this is how scientists reckon it really is. The wormhole passes down here. It's really easy to see that the wormhole path here is quicker, since you have to move a greater linear distance. Really greater linear distance. So the wormhole is just a shortcut through time and space. And now, you might end up in a different position in space. But you could end up in a different time. This could be a completely different time, and it could be, so if you come around this side, you might not get to that specific time. You might, if you travel nearly at the speed of light, but here, if you didn't, I don't know, take millions and millions and millions and billions of years, you would come here, and you would actually have time traveled through the wormhole. And that's why time travel is possible. But there was another theory. Cosmic strings. Cosmic strings like this. Imagine a two-dimensional cube, which represents the universe. There are many cosmic strings everywhere. So if you have a three-dimensional cube, in some point in the universe, there will be some cosmic strings. And you can go through those cosmic strings to time travel. So if you could pinpoint the exact point, pardon the pun, you could get through the two lines at exactly the same speed and exactly the same time. So the point where they intersect each other and twist, you could bend space-time. So if you went in this way, and then circled around, and then circled around it, and then twisted it, you come back before you even came. And now this could even lead to a bit of confusion, because you just went, and now you're already here. And you going down there at that exact point would see you. And now that could lead to a rip in the space-time continuum, but that's something else. So that's why the cosmic string theory is actually quite famous, even though it might not seem it's possible. But wormholes the wormhole theory is commonly known because it applies all the laws of physics, and there's nothing saying that it can't be done. And the key puzzle to this, the key ingredient for time travel, is anti-gravity. So, hope you enjoyed this video. Don't forget to leave a like, comment and subscribe for more videos like this, and thanks for watching.